Hey guys, welcome to another Corona tutorial. Today we are going to take a look at some examples of wrong scene setup, basically beginner mistakes that some people who are new to rendering or who come from other renderers may kind of do when they first encounter Corona and try to set it up. So what I've prepared is a scene that's basically kind of collection of all the possible mistakes when setting up and your scene when it comes to render settings, lighting and materials. And so as you can see, this is a quite noisy scene. There's quite a lot of noise pretty much everywhere, and the scene took 16 minutes to render in such small resolution on quite strong 6-core i7 CPU. So first thing we will inspect when fixing this scene is the render settings. So if we open it up, let's go first to the performance tab, because that's where most of the things affecting performance will be found. And let's start from top to bottom. So first mistake we can see is the secondary solver is set to path tracing while we are rendering interior scenario. For secondary GI in interiors, you should always use UHD cache. The reason it may be set to path tracing by some users is because they think that either path tracing will give them more correct results, or it will they will select path tracing because they think that cached GI solutions will create some kind of blotches or leaks. In Corona, UHD cache will often give you quite accurate results. There won't be any splotches or any leaks or anything like that. It will also give you probably better representation of light transport in interior, because UHD cache can do a lot more bounces than path tracing, a lot faster. So overall you will get actually, I think, better representation of lighting using UHD cache, because if the secondary GI is path tracing, the more of the ray clamping will occur, and the overall result may often be darker than it should unless you use unbiased mode. So we set this to UHD cache, and we go down and we see that GI versus AA balance is set to 64. And as the name suggests, this is balance parameter, this is not multiplier. And often people coming from other renders think that basically larger number means better quality. In Corona that is not the case, and this is indeed balance parameter that balances between global illumination and anti-aliasing. So it's a good idea to keep it at default unless you really know what you are doing. So for this value it doesn't apply that higher number always means better quality. So we will fix this back by setting it to 16. Then next one is light samples multiplier. Again, this is not really used to increase this number to increase quality. It is used to balance the amount of light samples with the amount of GI and AA samples. So unless there is any obvious noise in your direct illumination, you just don't increase it preemptively. You increase it only when there is a problem. When there's not problem, you keep it at default. So let's set it back to default at 2. Next one is max sample intensity. Again, we can see there's quite a high number. Usually in Corona 1.3 and newer, the error message dialog will warn you about this, but in previous Corona versions it won't. And what this does is, the higher the number is, the less of a ray clumping will occur. So the light transport will be correct, but also it will be more noisy and may cause fireflies. So the default value of this, which is 20, usually works perfectly for most of the scenes. You can sometimes, when you are after accuracy and you don't need very fast rendering, you can crank it up even to something like 100, but I really wouldn't go over that, and 20 is a great value. Also, value of 0 disables the ray clumping completely and switches Corona to so-called unbiased mode. Also, keep in mind that this parameter is not always meant to be increased. Sometimes when you are not after physical accuracy and you are just about you need renders done fast, it's, for example, non-photorealistic rendering and there's some noise from like indirect illumination, you can actually decrease this. Decreasing it to lower than 2 will usually make lighting and reflections a lot darker than they would appear in a real world. So I wouldn't go under 2, but like a value of 5 is completely fine, and it will speed up your rendering a bit, and you won't sacrifice that much of a physical accuracy. And the last one here is maximal ray depth, and again default here is 25, and there's not much reason to increase it, because increasing it will not give you any observable difference. If you render a comparison between 25 and 50, in most of the scenes you won't even be able to tell the difference. Also, for this value, if you decrease this value to and you expect to optimize your rendering speed using that, actually Corona, since it's modern path tracer, is not penalized so much by having increased ray depth. So whereas in Mensuray or V-Ray, for example, default ray depths are usually around 5 to 10. In Corona, 25 is fine. It will give you more accurate result. Increasing it won't bring you much difference. Decreasing it won't make your rendering much faster. So again, there's not much reason to touch this. Okay, so once this is done, let's inspect also system settings tab. And one thing some people may do is, for example, disable image filtering, and this is not really recommended because then you can get a lot of aliasing artifacts. It was sometimes suggested to do this in V-Ray when you're rendering stills, but Corona is not V-Ray, so I would suggest you keep this at default, and you can control blurriness of the filter by tweaking this with parameter. So 1.5 is usually the great value. I wouldn't go under that, but if you need your renders a little blurrier to make noise appear a bit cleaner, you can increase to like 2 or 2.5. So when it comes to the render settings, basically the scene tab doesn't contain much that can go wrong. You should start checking values, especially in the performance tab, and then also quickly inspect the system tab, especially the filtering, and also make sure that this update interval is not too small. It's basically how often frame buffer refreshes. So the default value of 1000 milliseconds means each 1 second, and if you increase it really low, like for example 10 milliseconds, that means frame buffer will update 100 times a second, and each update eats a bit of your CPU power. So if you update frame buffer so often, it actually a lot of your computing power may go to redrawing of frame buffer instead of actual rendering. So again, I would suggest to keep this at default. In general settings, there's not much that could go wrong, as I said. But one thing that people may do, especially newbies, is they may enable all these overrides and instance their environment map here under the assumption that unless they do this, their environment won't be visible directly for reflections or for refractions. That is not true. These are overrides. If you want, for example, different map in the direct visibility than the one that is your primary environment. but you don't need to have these enabled to see your environment directly in reflections in refraction. So again, we'll disable this. These come at very small performance hit, so unless there's no reason to use them, I would not enable them. The only point to enable them is actually when you need different environment for different ray types. Okay, so if we just click through it really quickly, we've basically now fixed all the problems in render settings, and we can go ahead and render again. Check out how our rendering looks. And as you can see, the rendering is now a bit faster. Previously it took us about 16 minutes to get a really noisy result, and right now when we look at it, we can see that already after 27 seconds we reached almost the same noise level as we did previously in 16 minutes. But of course there's a lot more mistakes in a scene, and one of them, as you can see, the walls and basically all the corners around look quite bright and washed out, and some of the corners look almost as if they were glowing. That means that some of the materials in a scene have a really high albedo. Albedo is basically diffuse brightness of the materials, and a lot of people coming from other renders or new to rendering will often tend to use extreme values for diffuse color, like 255 complete white. Since Corona is a modern path tracer, it does a lot of diffuse bounces, and therefore your renders with such unrealistically high diffuse values will often appear quite washed out. And also, since Corona uses Russian roulette optimization, if you have unrealistically bright materials, your rendering will be a bit slower than it should. Okay, so how to fix this? This is quite easy. The great thing to start is to add the C shading albedo render element, which is diagnostic render element that will be used to identify which materials in your scene have higher albedo. So let's render again and switch to C shading albedo, and we can immediately see that some of the materials are showing as white, and white means that albedo of these materials is unacceptable, and the materials may look unrealistic and they will slow down the rendering. So let's go ahead and let's pick these materials and fix them right now. So we can see that this material right here is very red, so let's pick that one first. And if we take a look at color, indeed there is completely white, super white albedo. That means this material reflects 100% of incoming light energy, and there's no such material in the real world. So for example, as a rule of thumb, I would suggest that for like bright alpine snow, which is basically, I think, one of the widest things you will encounter in nature, that will be like 230. For like painted wall in the interior, the average would be from 200 to 210. So let's set it to 200. And let's render again. And once we render, we should see that this material will turn darker color, which it does not. So let's make sure. Oh, I forgot to click OK. So here, let's try again. And as you can see, this material suddenly turned bright gray. That means the albedo is okay. So we have two more materials, or rather one more material to tweak. So let's grab this wall material right here. It's a little beige color. So again, let's set it to like 200 and render again. And again, we fixed most of the problem. There's one material down here. So let's again grab it and try to fix it. It's this material right here. Again, it's supposed to be white, so let's try like 210 here. And we can also see on these books the parts of the textures are white. If you have textures that contain color of some extreme albedo, then you can just pick the texture. There's a lot of books, so I'm not sure which one is it, but just to show you as an example, for example, this one, if we take a look, it has the white area here, and the chances are the white is completely white, means RGB 225. So what you can do about textures is just go here to RGB level and decrease it to something like 0.9, means 90% of the original albedo. So now if we render, I probably didn't pick the exact texture because it's multi-material, but as an example, if this is how your albedo render element looks and there are just some little red things here and there, then that's okay. So if we take a look at beauty, first thing we can do, we can see right now is that our render looks much more realistic. We are starting to get some nice contact shadows in the corners. We can see that our render is overall a bit darker than it should be. So one thing we can do when we correct our albedo and our render darkens or our scene darkens, we can just compensate for it by increasing the exposure. So again, we've increased the exposure. We can see that our interior has turned nicer and brighter. It doesn't look so washed out as before. It has some deeper shadows. So this is it for the materials. One more thing, we can see that the floor appears to have this weird shininess, like it appears to be a bit odd. That's because Corona uses new GGX shading model. And this shading model has its own Fresnel formula. So one of the things you should avoid is you can see it, for example, when getting like design connected models, they will have fall off map set to Fresnel, or sometimes they will have to set it to just perpendicular parallel. And this fall off map will be plugged into reflection color, and the reflectivity will have set the maximal Fresnel. That means the Fresnel curve is basically disabled. So you should avoid that. Instead, you should not map reflection color with fall off ever. And you should just use the built-in Fresnel here. So let's say for the wood floor, we would use like 1.6 and the reflectivity wouldn't be so large. So for the wood, like 0.55. So this is one thing to keep in mind. If you see fall off in the reflection slot, just pull it out, keep it empty, or map it with a reflection map if there's some, and use the built-in Fresnel. So again, let's render and see what we got. And we can see that the reflection on our floor now looks a bit more natural. And as we can see, our render time has again improved, but we still have a lot of noise in the scene, and we can continue to search for another problems. So the next problem the users will often do is using caustics, glass with caustics enabled as glass planes in Windows, which will slow down rendering tremendously and will introduce a lot of noise. So when you have glass planes that have some thickness like this one, then by default the caustics is disabled, and you should not enable caustics for any object, any glass objects that occlude most of your scene from lighting. So glass planes will occlude most of the rendered interior from the exterior, or all of the rendered interior from the light coming from the exteriors. So for this you will use glass with caustics disable. That will make glass to produce transparent shadows, and these transparent shadows will be a lot faster to compute. Also, you won't lose any lighting coming through, because if caustics are enabled, then those rays that go through the glass materials will be clamped by max sample intensity, and your lighting will be a bit darker than it should. Or if you have windows that are just one plane, which is actually the recommended way, if you have window glass that is just one thin plane without any thickness, then you can enable thin mode, and that will compute the thin film of the glass, like thin glass plane, which is useful in this case, and it will be the fastest way to render your scene with glass in Windows. So again, let's check out how are we doing. And you can see that our interior has brightened up a little bit once we fix the glass. So, oops, I did one thing that I didn't want to do, so let's re-enable the caustics in the duplicate material. And what I wanted to show you is here another common mistake was if you have artificial light source, and that artificial light source is enclosed in some light fixture behind the glass with caustics. That's the same problem that should not happen. So again, to fix that, you should either disable the caustics if glass has some thickness, or you should set it to thin if the glass doesn't have any thickness. And again, the thin option is currently the best option there is, so just make your glass one thin mesh and apply the thin wall glass, and you will see your light will now correctly shine through, and it won't create just a pool of noise we got there previously. So that's another thing to keep in mind. If you have any light fixtures, make sure that if it's covered, if the light source inside is covered by some glass, then just make sure that that your glass is either without caustics or thin. Another thing that you should keep in mind, let's hide this glass for a minute. Let's grab this. If your light source is very close to some material, and that material is really shiny or has high albedo, that can create a lot of noise because the material itself will be so much illuminated by the close by light source that it will be picked up by GI and it will create noise. So if you want to fix that noise, you can, let's just check which material ID this is. This seems to be free. So this material right here, which is brushed chrome. So if we just render, we can see what how hot this material is, how it turned completely white. Actually, I'm not sure it's the brushed chrome. Let's just, yeah. It's this one. Yeah, aluminum reflector. So to fix that, to make sure this material doesn't cause too much of reflective GI noise, what we can do is to use Corona ray switch material, and for the direct visibility, reflection and refraction we will use the R material, but for global illumination we will use just completely black Corona material. What this will do that the reflective GI rays will see this material as black, as completely black, whereas all other ray types will see it as the material that it is. It will decrease our accuracy of our lighting slightly, so you will see some difference of the light that would be reflected from the inside of the reflector, but it can save you a lot of render time because it will render a lot cleaner. So again, if we render the scene as it is, we can see that the scene again renders a bit faster. So let's give it a few seconds. And we can see the render time is now obviously better, but there's still a lot of noise coming from somewhere. So let's take a look where it is. And the last problem often people do is when they are setting a background, like the backplates behind the windows, they will use some material that actually affects global illumination. So instead of receiving the light from the environment, Corona Sky in our case, which is very fast and very optimized, I mean the lighting from the environment, they will create geometry outside of the interior, and this geometry will have some material affecting GI applied. So in this case, this is Corona material with enabled self-illumination, and it means that most of the ray casts from that are cast from the camera into the environment will bounce, and they won't hit the environment and computer lighting, but they will hit this self-illuminated material behind the window, which is very slow to compute, a lot slower than environment, and it will cause again a lot of noise. So what we can do here, if we want, if we let's say have our scene completed, lighting established, and the client says, I would just like to see this photo behind the window, the way you should do it is to use Corona light material, and this has multiplier 5, so let's set it to multiplier 5 as well and plug it into TextMap slot, but make sure the emit light option is off. Therefore our scene lighting will be computed strictly by the optimized environment light, but we will still see our background environment using the light material, but it won't affect direct lighting or indirect illumination of our scene in any way. So it will not make our scene any noisier, and it will not mess up our scene lighting that we have already established. So again, let's give it a render. And now we can see how our scene really lit up because the material was also occluding the sunlight. And now if we compensate for it by decreasing the exposure, let's say 1.5 or 1, now we can see that we've also reduced all that strong noise that we had around the window and on all of the surfaces. So now we have the backplate or the background that doesn't mess up our scene lighting. We have background that doesn't slow down our rendering. We have materials with a nice soft contact shadows that do not require much of ambient occlusion. We have our light that is shining on the floor here but is not causing any additional noise, and our scene is rendering quite fine. The last problem in this scene is if we take a look through the render elements, there is ambient occlusion pass, which is basically Corona text map with ambient occlusion, which user has prepared in intention to apply it in a post to multiply it over the beauty pass to get back all those contact shadows that were lost by using materials with super high albedo. So this pass may slightly slow down our rendering, and since our albedo is now correct, we do not need this pass anymore and we can just get rid of it. So let's render one last time. And let's switch back to our beauty. And now we can see that our render is going quite fast. It's just 20 seconds and we are already at noise level that was previously taking about 16 minutes. We can see also that we are receiving the reflections and also through the window plane the refraction of our background image, so we do not get reflections of the sky. We get real reflections of the image that is there, but at the same time the image is not messing up our lighting or slowing down our render. So as you can see, the minute has passed, the image is quite clean already. So I'm gonna pause the video here, and I'm going to get back to you in about 2 minutes, and let's see how our render looks. Okay, so we are back. The renders took 4 minutes, which is 1/4 of the 16 minutes we had before, and you can see the render is almost finished. There's just a little bit of soft noise that will resolve in another minute or two, but overall this is kind of quality you could already, I think, hand over to the client. So yeah, this is it for the common mistakes. We've over the past half an hour we've managed to fix the scene, all the usual mistakes that users could do. One more thing I'm gonna show you is more clearly is how the albedo or the wrong albedo can really affect the contact shadows. So let's now just reset the scene and create a new one. And I am going to create just a simple box. Let's create some simple room. Let's create some sort of window. Okay, like this. I'm gonna get inside. Let's create some random geometry so we can actually have something to compare all the concave shadows in. I'm gonna add a bunch of depots just so we see how it really looks. One here, let's put one here, let's put one here, one here, one could go here, another one could go here. Alright, that looks nice. Now let's just create our camera. Make it free, let's set the camera straight, so 90 degrees, 45 degrees, that looks fine. Okay, let's lock our camera. Let's just create simple daylight system. So Corona Sun, oops. Okay, that looks nice. Let's add Corona Sky. Open material editor. Corona material. Great. So let's call it clay. Let's set our render to be Corona, of course. There we go. And let's assign our clay material to everything. Now if we render, I am going to decrease the exposure, or rather I'm going to increase the highlight compression. Okay, so let's also add just a quick portal so that our rendering is even faster, so we don't waste so much time. Just Corona portal material. Okay, and now this is our, let's call it wall material. And let's use some crazy albedo like 250. It's not completely absolute, but it's crazy high. And let's render our scene. You can already see that raising the albedo itself has increased the calculation time dramatically. And we can also see that our interior has got incredibly overexposed. So let's compensate for it by decreasing the exposure. And you can see that our interior is incredibly washed out. You can see that there are like slight contact shadows under the teapots, but what we see is basically almost even flush bright gray color. Also, you can see there's quite a lot of noise everywhere, and that noise is not coming away too fast. So let's cancel this, copy it to max. Actually, let's open RAM player and load our channel B. So this is our reference render. Now let's say we would have some reasonable albedo for our white walls. Let's say 200. Let's render again. Immediately first thing you see, our render has gotten a lot darker. So first thing we will need to do, we will compensate the exposure for it, so we get the brightness we want. So now this is about the same brightness for the interior as with our high albedo render. So we got the brightness the way we want it. We don't need to render the image darker for that. But you can see how all the details in lighting draw out. And also you can see how clean compared to the render, how clean it is. So I'm going to cancel it here. I'm going to set it as RA. And here you can see the difference between albedo. Not only you can see that there's a lot more noise in the high albedo render, but it also looks a lot less realistic, a lot more washed out. So if we compare, the correct albedo makes our renders both more realistic as well as faster. So that's why it's so important to keep it in mind. So I hope you found this tutorial useful, and I'll see you next time. Goodbye.